Hi guys, welcome back to Derive. So in this video, we're going to derive the formula for the second scenario of the projectile motion, which is this. So the particle comes from the letter A and it falls back to the letter C, which has the same elevation. In simple words, it comes from the ground and it falls on the ground again. So guys, listen carefully because this scenario is the most commonly asked scenario of projectile motion in a board exam problem. So we're going to have a derivation and shortcut formulas for this. So we're going to derive the formulas for the following. So total time of flight from A to B, total time of flight from B to C, of course total time of flight from A to C, the horizontal range R, and the Y max. So we're going to start to derive at the time from A to B. So we're going to use again the straight line motion formulas for the vertical distance, and that was VF is equal to VO plus AT. And since that is vertical, earlier I said that just replace it by y, the subscript, or just add by y. So BOY minus GT. That's our consideration way back on the first video, because your acceleration for the vertical motion is of course the acceleration due to gravity. Okay, and your BOY is of course your VO sine sorry for my handwriting, BO sine theta. Oh my, I forgot to write a theta here. Yeah, the theta is here. So just substitute VFY is equal to BO sine theta minus GT. Okay. At point B, so the only approach here is that there's only one motion here, and that is the horizontal velocity. So By at point B is equal to 0. Therefore, your equation will become 0 is equal to BO sine theta minus GT. There you have it. So T from A to B is equal to BO sine theta over G. So there you have it. You have your first equation for the time from A to B. And as you notice, at point B there's the Y max. Of course, at the Y max you have no vertical velocity, and that's why your By at point B is equal to 0. There's only horizontal velocity at your Y max. Okay, so proceed tayo sa T from B to C. So as you can see, symmetrically we can just simply multiply that TAB by 2, and that will be your TAC. TAC pala is 2 times 2AB, because symmetrically ang hanapin na pala natin ngayon is TAC, not TBC, sorry. So your AB is equal to TBC symmetrically. So your TAC will become just double the TAB. So that was 2 BO sine theta over G. And there you have it. You have your second equation. So that was the total time flight from A to C, and that was the total time flight from A to B. Symmetrically, it is halved. So if you are going to get the time flight from A to C, just double this time from A to B. But para lang hindi natin masabing sa drawing lang tayo gumaze, we're going to derive it, of course, in another way. This total time flight from A to C. We're going to use the straight line motion formulas again, and we are going to convert it to vertical distance for projectile motion. So we're going to use, okay, sorry, black ink. Okay, S is equal to VOT plus 1/2 80 squared, not 80, 80 squared. So just replace it by Y is equal to b's of Y TAC minus 1/2, of course use G, TAC squared. Okay, so since our time here is from point A to point C, of course our Y at C is 0 kasi nasa ground na siya. So VOY, what is your VOY? BO sin theta TAC is equal to, equate na natin 1/2 GAT AC squared. So lagay ko lang sa taas, no? Okay, yan. So cancel of course yung isang T, so may matitira kang BO sin theta is equal to 1/2 G TAC squared. Okay, TAC rather. So just cross multiply, and there you have it. Your TAC is equal to 2 VO sin theta over G. Alright, so hindi lang natin basta binase sa symmetrical na curve, binase din natin sa pag-derive ng formula using this straight line motion formulas, and then kinonvert mo lang for the vertical distance. As I said on the first video, my explanation for the straight line motion converting to projectile motion is an integral or an important. So, just always take some notes, okay? So, saan na tayo? Meron na tayong TAB, TBC, of course, okay, unahin natin si Ymax. Okay, I'm going to litan ko lang konti so that we can derive more. Sorry. Okay, I will move my logo here. Okay, I will move my logo here. Alright, so yan. Okay, I will move again. Okay, so sorry for the delay. Okay, so we are going to proceed to Ymax. Okay, so Ymax. So our Ymax here will be, so we're going to use the straight line motion formulas again, but the third equation of that, and that is the BF squared is equal to BO squared. So palitan ko na agad guys ng negative G minus 2GS. Just add Y kasi vertical distance ang pinag-uusapan. Okay, so ayan, so since Ymax ang tinatanong natin, ang sabi natin kanina, there's no final velocity for the vertical distance at point B. Kasi ang Ymax mo ay nasa point B, so taking this as 0, so B or BOY squared is equal to 2GS. So I will replace my S by Ymax. Okay, so your BOY squared is BO sin theta, of course, square it, become 2G Ymax. So divide both sides by 2G, and there you have it. Your maximum height attained by the particle is BO squared sin squared theta over G. Okay, and there you have it. You have your Ymax. So finally, ang kulang na lang natin is yung range R. So our range R will be based on as I said earlier, our horizontal velocity is constant throughout its path, and we are going to use the simple s is equal to VO times time, and replacing s by r, range, is equal to VO, just put x because it is horizontal, so your VOX is of course your VO cosine theta, of course from A to C, so that's TAC. Of course guys, if the total time of flight from A to C is already given in the exam, so just multiply it by the angle theta and the initial velocity, and you are going to have the R. But if the TAC is not present and it's not given, we can simplify it further because you have your TAC here, right? So just insert your TAC here, so VO cosine theta times 2VO sine theta over G, and there you have it. You are going to have R is equal to 2VO squared sine theta cosine theta. What's happening? Alright, cosine theta. So ayoko ng pangit ang sulat ko. Yan. So cosine theta parenthesis for us to have a space anymore at sa ilalim. So ayan, simplifying, we all know on the trigonometric approach that 2 sine theta cosine theta is sine 2 theta. So ayan, 2 sine theta cosine theta. So simplifying it guys, para hindi masyadong maraming tinatype sa calculator, you have BO squared sine 2 theta over G, and there you have it. You have your fourth equation, which is the range. So guys, ang kahalagahan ng pagdederive is that you do not have to memorize all the formulas. So that's important if you memorize the formula, but one important thing is that you know where this came from. You know the principle, you know the theory, you know how to derive it in case you forget it. So this is my purpose of my channel. This is the purpose of my channel, is to derive formulas and of course give exercises later. So there you have it guys. You have already your time from A to B, from A to C, you have your range, and you have your Y max. So sa unit analysis naman guys, madali lang naman, because BO squared, let's try the unit analysis at the Y max. So at VO squared, of course you have the meters per second squared mo yan, edi may meters per second squared ka. Ang G mo is meter per second squared, so cancel ang second squared, may matitirang isang m, so that will be meters. Okay, so sa range mo naman you have, so that will be the same. So ang pinagkaiba lang guys is that wala lang tong 2. So guys, sorry, I forgot the 2 here. So ayun guys, there you have it. You have your 4 final equation. And tandaan, ito yung madalas lumabas na scenario ng projectile motion sa board exams, because may mga shortcut na kasi to and it's not that complicated. Okay, so just screenshot it, and if you have notes, so importante mag notes because note takers are history makers. Guys, for the next video we're going to derive naman for the third scenario, which is medyo crucial. I mean, mas medyo complicated, but isa-isay natin. Thank you guys for listening. Let us learn and let us derive. Thank you.